So alkanes, nice and popular with the A-level boards to the extent that even this first page can emphasize some things you need to know for the exams. So start off with A, nice and easy. 1, 2, 3, 4, so it's a butene. The double bond starts at carbon 1, so it's a 1-butene. And we don't have to worry about E or Z because carbon 1 has 2 hydrogens on it. To have to worry about E and Z, you've got to have 2 different things on each of the carbons of the double bond. Moving to B, 1, 2, 3, 4, 5, so it's a pentene. Double bond starts at carbon 2, so 2-pentene. Now in this case, however, we do have to worry about E or Z because both of these carbons have got 2 different things on them. Now we need to sort of add the hydrogens so you can emphasize that. But you see carbon 2 has a methyl group and a hydrogen. Carbon 3 has a hydrogen and an ethyl group. As far as to whether it is E or Z, we've got methyl obviously beats hydrogen on carbon 2. Ethyl beats hydrogen on carbon 3. The methyl and the ethyl are on opposite sides of the double bond. If you kind of turn your head a little bit so you're looking towards this double bond, so this is the bottom, this is the top, the methyl is on the bottom, the ethyl is on the top, which makes it E2-pentene. Moving to C, 1, 2, 3, 4, 5, so again it is a pentene. Carbon 2 is where the double bond starts, so 2-pentene. Put in the hydrogens just to really emphasize the point, and what we see here is that on carbon 2 the methyl, which beats the hydrogen, is on the bottom. On carbon 3 the ethyl, which beats the hydrogen, is on the bottom. So both of the top groups are on the same side, which makes it Z2-pentene. Moving now to D for a little bit of extra fun. Again, 1, 2, 3, 4, 5, so it's a pentene. The double bond starts at carbon 2, and remember that if there's nothing else except a hydrocarbon or halogens, the double bond determines where you start numbering. So carbon 2 is where it starts, that's 2-pentene. We do have this chlorine there, so that's a chloro, and it is also on carbon 2, so 2-chloro, 2-pentene. And now do we have to worry about EZ? Yes, we do. Carbon 2 has a chlorine and a methyl group. Carbon 3 has a hydrogen and an ethyl group. So both of the carbons, 2 different things. Is it E or Z? Well, on carbon 2, chlorine versus carbon, chlorine wins out. On carbon 3, carbon versus hydrogen, the carbon wins out. So again, tilt your head so you can look that this is the bottom, this is the top. Both the number 1 priorities, the chlorine and the ethyl, are on the same side, so that makes it Z. E, again we see a nasty little chlorine there. 1, 2, 3, 4, 5, so it's a pentene, again starting, double bond starting at carbon 2, so 2-pentene. The chlorine now is on carbon 3, so that makes it 3-chloro, 2-pentene. Again, let's add in the hydrogen there so we can see we've got a methyl and a hydrogen on carbon 2, so the methyl takes priority. And then, of course, we have chlorine versus carbon. Chlorine takes priority. So now you can see that the number 1 priority is on opposite sides of the double bond. The methyl is on the bottom, the chlorine's on the top, which makes it E. Now we look at one where you got to not be confused by the use of the symbols. Methyl is a carbon, so carbon 2, carbon 3, and then ethyl is another 2 carbons. So that means that the longest chain here is a pentene. Carbon 1, carbon 2, if we start there. If we start here, it's carbon 1, carbon 2, carbon 3. So we'll start here with carbon 2, so it is a 2-pentene. Do we have to worry about E or Z? Oh, excuse me, I'm getting ahead of myself because we've taken care of the longest chain, but we still have that poor little methyl there that is attached to carbon 2. So 2-methyl, 2-pentene. Now I shall ask the question, do we worry about E versus Z? And the answer is no, because carbon 2 has got 2 methyls on it. Remember, for EZ to be an issue, you've got to have 2 different things on both of the carbons of the double bond. Moving to this one, and longest chain, well, methane is 1 carbon, 2, 3. Butane is 4 carbons, so it's 1, 2, 3, plus another 4 is 7. So that makes this a heptene. Again, it's a 2-heptene because we start there. Anything not accounted for? Yes, that poor little methyl down there. So that methyl is now on number 3, so 3-methyl. 2-heptene. Do we have to worry about EZ? Absolutely, because this carbon has got a methyl and a hydrogen. The methyl is the top one. This carbon has a butyl and a methyl. The butyl is the top one. So methyl and butyl both on the same side, making this Z. And finally down here again we got carbon 1, 2, 3 and another 4 makes 7, so it's a heptene. Carbon 1, carbon 2, so it's 2-heptene. We've still got that methyl there, so that's on the 1, 2, 3 carbon, so 3-methyl, 2-heptene. But now if we look at the priority groups, methyl here on the bottom for the carbon 2, and then for carbon 3, butyl is the top priority on the top. So thus that makes it E. Wasn't that fun? Big, big, big emphasis on the A-level papers of that whole E versus Z, and the idea that you don't have to worry about E and Z isomers if even one of the two carbons in the double bond has two different groups on it.